Hello and welcome back to another Future Doc House production. We are continuing our journey on hypersensitivity. Type 4 hypersensitivity. We've got type 4 hypersensitivity, also known as delayed type hypersensitivity, or DTH. You might recall type 1 was immediate hypersensitivity, whereas type 4 is delayed hypersensitivity. Okay. This hypersensitivity is T cell mediated. It's in red, T cell mediated. And it's basically about two stories. The story of CD4 positive, which is a naive T cell, and CD8 positive, which is another naive T cell. The CD4 will eventually become a T helper cell, and the CD8 will eventually become a T cytotoxic cell. And CD means cluster of differentiation. All right, let's talk about the story. The story of CD4 positive becoming a T helper cell. First, a foreign antigen enters the body, obviously. Second, the APC, which is an antigen presenting cell, picks up the antigen. And what does the antigen presenting cell do? Well, it presents the antigen, okay? So we've got an antigen presenting cell. We've got a naive, so naive, these CD4s. We have a naive CD4 positive cell, and they link up. The APCs will present the antigen in the MHC class 2 molecule, and the CD4 has a CD4 receptor. That's the T cell receptor, the CD4 T cell receptor, and they're gonna hook up, okay? And that's going to lead to some reactions. One of the reactions would be the APCs will present a protein called B7, and the CD4 positive cell will present a protein called CD28. I know, it's all in red. Know this, memorize this, it's annoying. MHC2 you should know already, okay? CD4, well, the 4 becomes a TH1, so it's for help. So that's CD4. The B7, no, that's connected to the APCs. And the CD28, well, if there's a CD and there's a CD4, it's connected to the CDs. Here we go. This hooking up, this linking of these of the antigen and the receptor causes the release of interleukin 12, IL-12. Yes, more ILs. Don't worry, all these interleukins are different than the interleukins during the type 1 hypersensitivity, so that should help. If you can just separate these two and list the interleukins in the different hypersensitivities, you shouldn't be too confused. Yes, there's an interleukin 12 and it's released, and this causes the CD4 naive, CD4 positive cell to become a helper cell, a TH1 helper cell. Simple. Now we have a helper cell. Now we have a TH1 helper cell. Oh, sorry, effector cell. Now it's an effector cell, and this effector cell can release things like interleukin 2 and IFN gamma. These cytokines, interleukin 2, increases the TH1 proliferation, and the IFN gamma recruits the macrophages. Macrophages come into the picture, as well as helps TH1 proliferation. Macrophages coming to the scene now. Now we've got macrophages at the scene of this hypersensitivity reaction. And the macrophages release TNFs, interleukin 1 and interleukin 6. And these are all inflammatory cytokines. And these inflammatory cytokines produce an inflammatory response, such as inflammation. Wow, simple. Fever, redness, and swelling. So everything that you think of inflammation, that's what the macrophages are doing by releasing the TNF, interleukin 1 and interleukin 6. Now don't get that confused, because they also release other stuff, which is down here. Macrophages also release ROS, reactive oxygen species, for, killing bacteria usually, but it's also damaging to the tissue. Lysosomal enzymes and complement components, which all damage the tissue damage. So macrophages can be very destructive. Not only are they used for phagocytosis, but they also release all these fun stuff, the inflammatory factors and the tissue damage factors. All right, cytokines. Well, tissue damage, not cytokines, but the cytokines for inflammation and the chemicals for tissue damage. Note that APCs also release interleukin 6, as well as TGF beta, which is transformation growth factor, TGF beta, which creates Th17. Oh, another helper cell, yes. But this helper cell releases IL-17. Now that's simple, Th17 releases IL-17, same number. And this recruits the neutrophils, yay! So that's where the neutrophils come into play. So there's macrophages, there's neutrophils, there's different chemicals that, get to this point. All right, let's talk about story of CD8. CD8 is the naive cell, they're so naive, the naive cell of CTL, cytotoxic T cells, okay? And cytotoxic T cells? Cytotoxic CTLs. I don't think I wrote that wrong. CTLs. Anyways, cytotoxic T cells, okay? And the foreign antigen enters the body. Any nucleated cells will pick up this antigen, say a virus, say, it could be anything. It's, it just, virus or anything. It picks it up, okay? And any cell, which all nuclear cells has an MH class 1, would have the antigen presented on the MH class 1. And the CD8 would present its, not present, but have a T cell receptor of CD8 linking up to that MHC1, okay, and class 1, and it will say, oh, this antigen is no good. We need to release things. And the CD8 would immediately release perforin and granzymes. The perforins will create pores in the cell, and the granzymes will cause it to apoptose. So basically, the cytotoxin, the killer, would just basically kill the cell, and in doing so, probably kill everything else in that process. So that's the CD8, the cytotoxic T cell. All right, the diseases that type 4 hypersensitivity causes. Well, this is not really a disease. This is a test for tuberculosis. It's called tuberculin test. It's the tuberculin protein, and that's why it's called a PPD, a purified protein derivative. And this can cause interferon gamma and TNF beta to be released by yours truly, the macrophages. Yes, the macrophages, and cause the inflammation and swelling and this response, this inflammatory response. And boards love to ask you a question that the patient had a BCG vaccine, which is the Bacille Calmette Guerin vaccine, which will come up as a positive PPD result because of the inflammation response to the antigen, to the tuberculin protein. All right, let's talk about other stuff, fun stuff here. What we got here? We've got contact dermatitis. This is a fun one because poison oak, ivy, and sumac, they're everywhere. They're pretty much ubiquitous. You will see a patient with this type of reaction, this type of contact dermatitis. And not only poison oak, ivy, and sumac can cause this, but also nickel and any other skin allergies that a patient might develop because of the hapten carrier mechanism, where a little bit of a molecule from, say, something that they happen to be allergic to gets carried on within their protein, and it becomes a big contact dermatitis problem. All right, we've got CD8. This is an example of a question. So obviously a CD4 and a CD8 can cause a lot of tissue destruction, but say they ask you a question, how does the cytotoxic cells cause the destruction in contact dermatitis? And you know, CD8 cytotoxic T cells, that's IFN gamma, interferon gamma is also released. So that's where that would come into play. Also, there's also the perforating granzymes that causes the apoptosis of tissue cells. So you can also, depending on how the question is worded, answer to the best of your ability what they're asking for. Because a lot of these things can be correct, but if they're asking for a specific cytokine or a specific chemical that's involved in this type 4 hypersensitivity, that's where you can get confused, because everything is very confusing. There's IL-12, IL-6, IL-1, there's IFN gamma, TGF beta, it's insane. CD8, CD4, CD28, well, that's a little bit easier. Moving on. We've got these 4, which is all kind of gut related: inflammatory bowel disease, celiac disease, and Crohn's disease. Look it up. They're pretty interesting gut diseases that are triggered by a type 4 hypersensitivity. I wanted to make a special mention about this autoantibody T cell mediated response. I don't remember this. Maybe I didn't pay attention in school as much as I should have, but apparently this is a thing where these autoantibodies are eliciting a T cell mediated response, and we've got Hashimoto's thyroiditis, which is hypothyroidism due to type 4 hypersensitivity. We've got rheumatoid arthritis, self-explanatory. IDDM, insulin-dependent diabetes mellitus type 1, with the destruction of the B cells because of the type 4 hypersensitivity. Guillain-Barré syndrome, which again, due to the type 4 hypersensitivity, we've got destruction of the peripheral nerves, thus ascending paralysis. All right, so that's hypersensitivity. We finished. If you like this video and you want more of these videos, please click subscribe. Thank you and have a nice day.
Congratulations, you are a medical student. One day, you will be a qualified doctor and your home will be a hospital or a clinic. But for now, your journey begins in the lecture hall. You will listen to countless hours of lectures and spend evening after evening in the library reading page after page of medical theory. And guess what? This is the easy part. The hardest part is retaining your medical knowledge so it's there when you need it. For example, examinations. But don't worry, we are here to help. Meet Jeff. Jeff is a good student. He goes to all his lectures. He says no to parties so he can stay late in the library. But when it's time to take the exams, Jeff freezes. The knowledge that he spent so long learning just isn't there anymore. Now meet Jennifer. Like Jeff, she is a good student. But instead of just reading textbooks late into the night, Jennifer uses technology to help her study. She also watches lectures on YouTube and practices her knowledge with QUPI, a medical quiz app and online platform. Jennifer likes QUPI because it has 10,000 practice questions covering her entire medical course. This means she can practice her medical knowledge from anywhere and in a way that actually prepares her for the exams. Because she is practicing with exam-style questions, when she takes real exams, she'll be ready. Don't be a Jeff. Begin your 7-day free trial with QUPI today.